So apparently, there's a 10-minute time limit, and everybody knows I talk a lot, so I guess I got to speed this sucker up. If you plug those values in to this limit, directly substitute the 2 in, we get a value for the limit of 4/3. Moving on, the next method, if you cannot directly substitute a method for rational functions. It says over there, use when you have a rational function. If you would substitute and get a denominator of 0, what we're going to do is, if possible, simplify the expression so we can factor and cancel common factors, get LCDs if needed, until we get to a point where hopefully we can directly substitute. For example, the limit as x goes to 1 of the function x squared minus 1 over x minus 1. I cannot directly substitute in a 1 into this function because I would be dividing by 0. 0 divided by 0. I can, however, algebraically manipulate this by factoring the numerator. X squared minus 1 is x minus 1, x plus 1, and the denominator is x minus 1. A x minus 1 can be factored, canceled out of both the top and the bottom. No puppies will be killed. The limit as x goes to 1 of x plus 1. In this simplified version, now I can directly substitute in. When I directly substitute in a 1, I get a value of 2. Another example, limit as x goes to 2 of the function x minus 2 over x squared minus x minus 2. Again, you could try, but I cannot directly substitute the value of 2 into this function. I would have a 0 in the denominator, which is fine, but when you plug a 2 into the denominator, I'd also get a 0, not fine. So we will need to, again, factor and simplify this. X minus 2 on top, and on the bottom, x minus 2, x plus 1. And I'm running out of room, but you get the idea. The x minus 2's will cancel. So I have the limit as x goes to 2 of 1 over x plus 1. When I directly substitute a 2 in now to this function, I get a value for the limit of 1/3. Another method that may need to be used is rationalizing the numerator and denominator. If you have a radical function that you cannot directly substitute into, you may need to rationalize to change its form to get a form that you can directly substitute into. So this is going to be, we're going to talk about multiplying by the conjugate. It's a word we've talked about a couple times. Simplify, again, till we get to a point where I can directly substitute. So the example we will look at, the limit as x goes to 8 for the function square root of x plus 1 minus 3 over x minus 8. I cannot directly substitute an 8 into this function, again, because I'd be dividing by 0. So I am going to rationalize the numerator in this case. I'm going to multiply by the conjugate of the numerator, which is square root of x plus 1 plus 3. And to keep this balanced, I'm going to multiply by that conjugate the numerator and denominator. I'm really multiplying. What I have in green there is a fancy way of writing the number 1. The top will need to be FOILed. I have square root of x plus 1 times square root of x plus 1, which is just x plus 1. My inside and my outside terms will cancel. That's why I'm using the conjugate. 3 times the square root of x plus 1 minus 3 times the square root of x plus 1 cancels out. And then my last term, negative 3 times 3, is negative 9. On the bottom, I am just going to leave this, not factor it out, for a reason you will understand momentarily. My numerator simplifies. X plus 1 minus 9. I can simplify to x minus 8. Now you're probably understanding, hopefully, why I left the bottom factored, because I have a common factor of x minus 8 that I can cancel out of both the numerator and the denominator. So my simplified version now is 1 over the square root of x plus 1 plus 3. Now I can directly substitute an 8 into this function. I would have 1 over square root of 8 plus 1 plus 3. Square root of 9 is 3. 1 over 3 plus 3 is 1 over 6. Last problem, last type we're going to talk about today at least, is piecewise functions. And in order to evaluate algebraically the limit of a piecewise function, you're going to need to consider each of these sides separately. See if you can directly substitute in. If you can't directly substitute in, see if you can use any of the other strategies we used. Otherwise, you'll have to consider numbers that are closer and closer to the value you're approaching and think about the value from each side. So for example, the one I want to look at here, the limit as x goes to 0 for the piecewise function 2 plus 3x for values of x that are greater than 0, and the square root of 4 minus x for values of x that are less than 0. We do not have to graph this piecewise function to find the limits, although you could. I'm going to consider from both sides. The first piece, if my value of x approaches 0 from the right side, this first rule is when x is greater than 0, so that would be the right side. I would be using the rule 2 plus 3x. Remember, for a limit, it doesn't matter what happens at the value. This function is undefined at 0. I'm interested in what happens as I approach 0. I can directly substitute a 0 into this. When I put a 0 in, I would get a value of 2. I'll also consider what happens as I approach 0 from the left side. If I'm approaching 0 from the left, I'd be using the second piece of this function, square root of 4 minus x. Again, I can directly substitute a 0 into this function, and I would get a value of 2. Because my left-sided limit and my right-sided limit are both equal to each other, I can now say that the limit as x approaches 0, the two-sided limit for this piecewise function, is equal to 2. Again, because my one-sided limits are equal to each other. At this point, you can take a moment to pause the video. There are a number of problems for you to try. And then you can check back in when you're done, turn the video back on to see if you got the answers correct. All right, at this point, for the sake of time, I am going to give you the correct answers. If you need more explanation as to where any of these values come from, we can go over these more tomorrow when I return to class. So the first problem A, the value of that limit, you would need to factor and cancel out common factors, and then you'd be able to directly substitute in and get a value of -9. For B, again, you're going to need to factor, cancel out a common factor, and you'll be able to directly substitute in to get a value of -1/3. C, you can just directly substitute in there right away and get a value of 85/6, or if you prefer mixed numbers, that's 14 and 1/6. Problem D, you're going to need to rationalize to get to a point where you can directly substitute in and get a value of 1/6. Problem E, again, you can directly substitute in this one. No other algebraic work is needed to get a value of 1/5. Problem F, piecewise function. If you consider the limit from both the left and the right side, from the left, the function will be approaching 2. From the right, the function will be approaching 1. Because those one-sided limits are not equal to each other, the two-sided limit does not exist. Letter G, that cannot be directly substituted into, so you will need to factor and simplify. So you can directly substitute in and get a value of 1/5. H, you will need to multiply by the conjugate to simplify, being very careful with your negatives, distributing the negatives when you do so. When you directly substitute in, get a value of -1/4. And then the last problem, another piecewise function.